Good afternoon, class. Today we're going to cover the last two sections, 1.8 and 1.9 for Chapter 1. The first one is just talking about introducing equations. Section 1.9 we'll talk about has to do with working with equations and patterns. First thing we're going to talk about is a definition here. So our definition that we're going to refer to is a solution. A solution is something that makes an equation true. So an example up here, x plus 2 equals 9. X equals 7 is the solution to this equation because it makes the equation true. So now 6 is not a solution for this equation because if we put 6 in, 6 minus 4 is not equal to 10. So this would not be true. That would be an example of something that's not a solution. So when you're looking for a solution, you're looking for what's going to make it true. So let's look at here. We're going to try to classify these as true, false, or open, meaning we don't know if they're going to be true or not. So in this example, we have 3y plus 6 equals 5y minus 8. Well, since we don't know what y is in the problem, we can't conclude whether this is true or false. So we're going to consider this one to be open because we don't know what y is. So since we don't know what y is going to be, we're going to leave it as an open-ended question. So anything with a variable is going to be open unless we can solve for it, which we will learn how to do that in the next chapter. 16 minus 7 equals 4 plus 5. So in this case, there's no variables. All we have to do is calculate. So 16 minus 7 is going to be 9. And 4 plus 5 is also 9. Well, since we get the same thing on both sides, this one is true. And our last example here, 32 divided by 8 is going to be 4. And 2 times 3 is 6. This one is not true, so this is false because we get two different answers. So you're going to be in your homework being able, or classwork, and being able to explain or classify why something is true or open-ended or false. Now, identifying a solution. Once they give you something that they think is the solution, we can test it by putting it into the problem. So in order for us to determine if m equals 1/2 is a solution, we're going to put it in for m and calculate it. So anytime we input a variable, we're going to put parentheses and put that number in its place. This is called a substitution. We're going to substitute. So now we just have to do some calculations. Follow your order of operations. So we're going to have to do 6 times 1/2. If you don't have a calculator, then you're going to have to multiply the numerators, the denominators, and then simplify. 6 over 2 is 3. 3 minus 8 is negative 5. And that is what we wanted. So the answer to this one is yes. M equals 1/2. That is a solution because we were testing. Had we gotten a different answer than negative 5 down here, then we would have said no solution or not a solution. You're going to be dealing with some word problems today, and you're going to build an equation. So in this case, we have the length of a ball court at La Venta is 14 times. So remember what times is, that's multiplication. So we're going to multiply here the height of its wall. So we want to write an equation that can be used to find the height of a model of the court that has a length of 49 centimeters. So the length of the model court, okay, is what we're going to try to find or be given. Is means equals in our problem. 14, and remember times, and we're going to need to identify a variable here. So 14 times, let's let either h or w represent the height of the wall. So let's use h. So the length of the court will equal 14h. So there is our equation for this model. And that's all they wanted us to do, was write that equation. Okay. Now we can actually find for this 49 in the problem. Since we know that the length is 49, we can actually put that in for L to finish the equation. So we could do 49 equals 14 times h. Later on, we'll actually be able to solve for h. Since they're just asking us to write an equation to represent it, just put the 49 in for what the length represents. Now, we're going to use mental math to find a solution. Again, a solution is what makes the equation true. So what could we subtract from 12 to get 3? So we need to just do some trial and error. So you could do 12 minus 8 and see what you got, and 12 minus 9 and see what you got. So by trial and error, you could actually figure out whether what the solution is for y. So we could try 12 minus 8, and we would, with 12 minus 8, you would get 4. Well, that's not what we wanted, so 8 is not a solution. Y equals 8 is not a solution. So now we just try the next number. We're close. We're by 4, so 12 minus 9 is 3. So y equals 9 is the solution. And that was just by trial and error. Now we're going to do section 1.9, which involves patterns, equations, and graphs. First thing we're going to talk about is inductive reasoning. We in the last section, we talked about deductive reasoning. I think that was section 1.7. Deductive reasoning is where you're using some equation or definition to prove something is true. In this case, inductive reasoning is kind of a trial and error or an observation to get the right answer. So if we look at this, if we wanted to determine what the pattern was for this, we would have to determine what's going on between the items in this column to get the value over here. Well, we can see to get 1 from 1, we could either add 0 or multiply by 1. To get 2, we could add 2 or multiply by 2. Here, to get 9, we could add 6 or multiply by 3. To get from 4 to 16, we could add 12, or we could multiply by 4. So it appears the pattern, as I see it, we could times by 1, times by 2, times by 3, times by 4, times by 5. So it appears that we're just multiplying by the same number. So in this case, to fill this block, we would get 25. So you're going to find problems like that where inductive reasoning is needed, and you're just going to determine, kind of by guessing and checking the pattern, what that answer is. Now we're going to talk about the solution to an equation with 2 variables. The solution to an equation with 1 variable is just what that variable equals. When we have 2 variables, we're going to write it as an ordered pair. So in an ordered pair in this case, x and y, x is always the first number, y is always the second number. So we can check an ordered pair given to us to see if it's a solution by substituting it in. So in this case, x is 5 and y is 20. So we're just going to go over here and check. Put 20 in for y. Again, put parentheses when you're going to put a number next to a variable and substitute. So in this case, 4 times 5 is 20. And it works out. Put a little check there. So 520 is a solution. Had we not got the correct answer down here, had we not got 20 on both sides, then we would have said it's not a solution. Now we're going to talk about building an equation from a table and then graph that. Will runs 6 laps before Megan joins him at the track. They run together at the same pace. How can you represent the relationship between the number of laps Will runs and the number of laps Megan runs in different ways? So let's just deal with the table first. So let's start with Will down here has run 6 laps, and Megan has not run any yet. Once Megan has run 1, Will continue to run. So these are going to go up all by ones. And what do you notice over here is that these are also going up by ones, but they're always going to be 6 more than the top number. So we could represent that as an equation down here and just let x represent the number of laps Megan has run. So we could say that Will is going to be y. So Will here is going to be the y. Will is always going to be whatever Megan is, x plus 6. So there's your equation. And we can represent that using a graph as well. All we have to do is plot our points. So we will let Megan be down here. That's going to be the x. And we're going to let Will be here, and that's going to be the y. So each ordered pair from up above, we're just going to graph on here. So 0, 6. And then we're going to go over here. We can skip up to 2. And remember, there are always going to be 2 more, or 6 more, excuse me. 2, 8, 4, 10, and so on. They just have to stay that many, or 6 apart. So we just end up with a graph that represents a line going up. Okay. So you're going to represent using a graph, or using a table, or an equation. 3 representations for that problem. So bring your notes to class, answer the questions after the video, and we'll do some classwork tomorrow.